How do you lift more than 2 million stone blocks into the shape of a mountain, using no iron, no wheels on site, no pulleys, and no modern machines? The Great Pyramid of Khufu once rose about 146.6 meters above the Giza Plateau. Many of its limestone blocks weighed 2 or 3 tons. For 4,500 years, that scale has drawn awe and sometimes stranger answers. The evidence on the ground points in a more demanding direction. Quarry trenches, riverboats, damp haul roads, temporary ramps, measured lines, written accounts, and thousands of people working under the authority of the Egyptian state start at the floor of the plateau. Around the pyramids, the bedrock is scarred where limestone was cut out close to the building site. The builders did not need to drag every block from distant hills. Much of the inner core came from Giza itself, from quarries opened beside the rising monument. In the glare, quarrymen cut channels around a block, swung stone hammers, drove tools into seams and levered along the natural beds of the limestone. A trench would deepen by handspan after handspan until the block could be freed. These core stones did not all require polished faces. Many were roughly squared, set in courses, and tightened with packing stones and mortar. The perfect triangle, we remember, began as a dusty industrial field of cut faces, broken chips, wooden levers, and men judging which stone was good enough for which place. The outer skin demanded finer work. The best white casing limestone came from Tura, across the Nile on the east bank, where crews cut high-quality stone from galleries and quarry faces. Those blocks would later be dressed to a close fit, turning the stepped mass into a bright, smooth surface. Far to the south, at Aswan, workers quarried granite for internal chambers and heavy beams. Granite resisted copper tools. It had to be battered with dolerite pounders. Dark, hard stones lifted and dropped again and again until channels bruised their way into the rock. The unfinished obelisk at Aswan belongs to a later age, yet it preserves the same hard logic. Trenches cut around a huge mass, tool marks clustered in patient rows, stone trapped where the final separation failed. It shows the kind of punishment Egyptian quarrying could bring to hard stone. After the block was freed, the next problem was distance. The Nile carried the weight of Egypt. During the annual flood, water reached closer to the desert edge through channels, basins, and harbour installations. Stone that would have been brutal to haul across land for hundreds of kilometres could move by boat with the current, or against it under sail and tow. This was not improvisation. Egyptians had lived by the river long enough to understand its seasons, channels, winds, sandbanks, and landing places. A rare document lets us hear that system at work. At Wadi al-Jarf, on the Red Sea coast, archaeologists found papyri from Khufu's reign, among the oldest known papyrus documents. In the diary of an official named Mera, a crew transports limestone from Tura to Akhet Khufu, the ancient name of Khufu's pyramid complex. The entries have the flat force of administration. Days counted, officials named, inspections made, movements recorded. A delivery mark on papyrus brings the pyramid down from legend into a working calendar. Mera's men load at Tura, travel through Nile channels, report to supervisors, and return to repeat the journey. The diary does not reveal every building method, but it anchors one crucial fact. Casing stone reached Khufu's pyramid by organised boat transport under written supervision. At Giza, river cargo met the desert. Archaeology has revealed harbour and basin evidence near the pyramid fields, though the exact arrangement in Khufu's day is still being refined. Imagine boats nosing into a landing place, ropes drawn tight around posts, crews shouting as blocks come off the hulls. Officials check loads, scribes mark what has arrived. A missing shipment of rope, timber, copper tools, beer, or stone could slow the day as surely as a broken sledge. The causeways and harbour zone made the plateau a working edge, where waterborne supply became desert construction. From the harbour, the stones still had to move across land and upward. Egyptian art gives a vivid clue, though from centuries after Khufu. In a tomb at Deir el-Bersha, a colossal statue is shown on a wooden sledge, hauled by rows of men, while one worker pours water in front of the runners. The scene is later than the Great Pyramid, but the physics is credible. Experiments show that sand with the right moisture can reduce friction. Too dry, it piles before the sledge. Too wet, it turns heavy and soft. Dampened correctly, it binds and firms under pressure. On a prepared road at Giza, a limestone block sits on a wooden sledge. The rope ahead of it is wet with sweat and river water, biting into palms as the hauling team leans forward. A man walks before the runners with a jar, darkening the pale track. The overseer calls the rhythm. At the shout, bodies pull together and the sledge shifts. It moves because friction has been managed, because the load is balanced, because the surface has been prepared, and because the pull happens as one action, rather than many separate efforts. Simple equipment becomes powerful when timing and surface are controlled. Then the pyramid begins to rise, and the problem changes. Some form of ramping remains the strongest explanation, although the exact layout at Khufu's pyramid is uncertain. That uncertainty should be stated plainly once. Mud brick, limestone chips, gypsum, and compacted debris could form temporary inclines. After use, they could be dismantled, quarried away, buried or erased by later building and erosion. We should not expect a complete ramp to survive from base to summit like a diagram left for us in the sand. At the beginning, the work was wide and heavy. The lower courses held most of the pyramid's mass. Crews needed to move great numbers of blocks, but the lift was still modest and the space around the structure was broad. A straight or broad ramp, a prepared roadway, or several approach routes could feed the lower levels. The work then was a matter of volume, stone after stone arriving, turning, sliding into place, courses spreading across the large base. Higher up, the same method would become less efficient. The pyramid narrowed, the available working room shrank, and each new course demanded a greater climb. A ramp that served one level might be lengthened, shifted, cut back, or replaced. Routes could run along a face, turn around a corner, climb in shorter stages, or meet temporary platforms where blocks were re-roped and redirected. Levering may have helped with final positioning. The builders were solving a moving problem. Every course they completed changed the shape of the construction site beneath their feet. At the end of that process, the ramps had to disappear. Workers stripped away the packed debris that had carried the stones upward. Casing blocks were dressed and adjusted. Temporary roads that once clung to the monument were pulled down, leaving the clean geometry behind. A ramp being dismantled is an important image. Baskets of rubble passed down, retaining walls broken, the last work surface erased so the pyramid could become what it was meant to look like, effort converted into permanence. The workforce behind this effort was organised, housed and fed. Excavations near the pyramids have uncovered a large workers' settlement with bakeries, brewing areas, fish processing, administrative ceilings and long galleries that may have housed rotating crews. Before dawn, a baker's oven glows red in the settlement, while dough is slapped into shape for men who will spend the day hauling, cutting, carrying or measuring. Beer jars are filled, fish is processed, animals are slaughtered. The pyramid required stone, but it also required breakfast, water, sandals, sleeping space, medical attention, and a dependable chain of supply. The old image of slave gangs building the pyramids does not fit the Giza evidence. The work was still harsh, and state obligation could be coercive. A likely picture is a mixture of permanent skilled teams, seasonal corvée labour, specialist supervisors, and rotating crews drawn from across the Nile Valley. The flood season altered agricultural work, making labour available for royal projects. Men arrived in named groups, ate from central stores, slept in planned quarters, and answered to foremen whose authority came from the state. Nearby cemeteries add a human weight to the organisation. Workers were buried with care close to the monuments they helped build. Some skeletons show healed fractures and signs of treatment, evidence that injured labourers could be tended rather than simply discarded. This was a hard system, not a gentle one, but it depended on skilled bodies staying alive and useful. A quarryman with a practiced eye, a sledge crew that knew its rhythm, a surveyor trusted with a line, and a foreman able to keep supplies moving were all assets the state needed to preserve. Even the stones sometimes preserve the names of crews. Hidden graffiti inside pyramids and related monuments record work, gangs associated with Khufu. These marks were left in spaces not meant for public display, where later visitors were never expected to stand. They belong to the building process itself. A team name, daubed on stone, is a small act of presence, the mark of men counted by the administration, grouped for labour, and perhaps proud of their place in the king's project. Accuracy was another form of labour. The Great Pyramid is aligned very close to the cardinal directions, and its base was laid out with remarkable control. No steel instruments or modern lasers were needed. Egyptian surveyors had measuring rods, plumb bobs, squares, sighting tools, ropes, stakes, and a standard unit, the royal cubit of about 52.3 centimetres, divided into palms and fingers. They also belonged to a culture accustomed to measuring land after the flood, when field boundaries had to be restored and recorded. Picture the foundation before the first courses rose, a line stretched taut between stakes, a trench checked for level, a plumb bob hanging still in the morning air. Surveyors repeat measurements because a small error at the base becomes a larger error above. At night, specialists may have watched the northern sky. Several scholarly proposals explain the pyramid's orientation through observations of circumpolar stars, whose movement around the celestial pole could help establish true north. The exact method is debated, but the work itself is easy to imagine. Men waiting in clear desert air, sighting along a cord or instrument, converting the motion of stars into lines on the ground. Precision was used where it mattered most. The casing, base, and main passages demanded high skill. Core masonry could be rougher. Granite beams required pounding and abrasion. Limestone could be shaped with copper chisels, saws, mallets, and sand. The achievement lies in the disciplined use of tolerances. The builders did not polish every hidden block to perfection. They reserved time and labour for the surfaces, chambers, alignments, and joints that carried the structure and defined its appearance. This physical record is why more exotic explanations fail. The pyramids are astonishing, but astonishment is not evidence for lost machines or non-human builders. At Giza and beyond, the traces point to Old Kingdom Egypt. Quarries with tool marks, papyri with deliveries, harbours and causeways, sledges and ropes, workers' housing, bakeries, ceilings, crew marks, survey lines, and the long development of royal stone building before Khufu. The harder story is also the more impressive one. A centralised state learned to command landscape, labour, food, writing, and measurement on a scale few societies had ever attempted. Questions remain. Scholars still test models for the exact wrap, arrangements, the size and rotation of the workforce, the layout of Khufu's harbour system, and the astronomical or surveying method used to establish north. New finds can sharpen the picture, as Mera's diary did when it placed a working crew and Tura limestone inside the reign of Khufu. Missing scaffolds do not mean missing builders. Temporary works are often the first things a finished monument consumes. So return to the opening question. How do you lift more than 2 million stone blocks into the shape of a mountain without iron, wheels on site, pulleys, or engines?
You do it by cutting the mountain into pieces before you build it. You quarry a block from the plateau and another from Tura. You load a boat when the river allows it. You mark a delivery on papyrus. You drag a sledge over damp ground, the rope burning in the hands of men pulling to a shouted count. You feed those men from ovens lit before dawn. You measure the base again, watch the stars again, raise the ramp again, and take the ramp away when its work is done. Khufu's pyramid was not a miracle machine. It was a state, a river, a workforce, and a landscape moving in coordination. Its grandeur comes from the multiplication of ordinary actions until they become almost impossible to grasp. They lifted the mountain by breaking the impossible task into thousands of controlled, recorded, repeatable acts. When the last temporary road was stripped from the face and the white casing caught the sun, what remained was more than a tomb. It was the visible shape of an entire society made to move in one direction.